Okay, in example 5, we've got multiple factors all being raised to the power of 3. And what the rule says is that if you have multiple powers raised to another power, every one of those factors on the inside is going to feel the effects of that power of 3. So I'm going to think of this as negative 3 cubed times c squared cubed times d to the 5th cubed. So again, this power of 3 is really affecting every one of those things on the inside. Now let's just go right down the line and cube all of these things. Negative 3 cubed is negative 27. C squared to the third is c to the 6th, because when you raise a power to a power you multiply. And d to the 5th cubed is d to the 15th. The trick in these problems for me is just never to go too fast. Just take it one step at a time, there's no rush, and you'll be much less likely to make a careless error than if you were to do multiple things in a single step. That's where the careless errors occur. Now, in number 6, we have a fraction to a negative exponent. And on the very first slide, when we reviewed all of the rules, there was a specific one for this case. If you have a fraction to a negative exponent, you're going to flip the fraction or reciprocate the fraction and make the exponent positive. So this is going to become 3 over x to the 4th power. Now, there's another rule that says if you have a fraction raised to a power, then both the numerator and the denominator will feel the effects of that power. So now I can think of this as 3 to the 4th over x to the 4th. Well, 3 to the 4th, of course, is 3 times 3 times 3 times 3, which is 81 over x to the 4th. And at this point, I've exhausted all the rules of exponents. There's really nothing more I could say about this, so this is our final simplified answer. Okay, moving to number 7. Here we have a fraction raised to the power of 5. Everything on the numerator will feel the effect of that 5, and everything in the denominator will feel the effect of that power of 5. So there's a lot of things going on here. So again, I'm going to follow my own advice and just go nice and slow. I'm going to start by raising every single individual thing to the power of 5. Okay, so negative 3 to the 5th is negative 243. A to the 5y to the 5th, raising a power to a new power we multiply, so this would be a to the 25y. In the denominator, I've got a to the 6y, then to the 5th. Again, we multiply the exponents, so that's going to be a to the 30y. B to the 4th, then to the 5th. We're going to, for a third time, multiply, so now we're going to get b to the power of 20. Now, we're not quite done yet. If I focus my attention right here, and I'm going to put a little circle, or not quite a circle, but a blob around this, that numerator and denominator have the same base. And the rule is, if you're dividing and you have the same base, you should subtract the exponents. Now you have a choice of bringing the 30y up and making it a to the negative 5y, or you could bring the 25y down and make it a to the positive 5y on the bottom or in the denominator. Since we're trying to end up with just positive exponents, I think I'm going to do my second choice. And I'm going to bring a to the 25th y down and join it with the a to the 30y. I hope that doesn't get cut off. Sometimes if I write a little bit close to the edge, it goes away. But yeah, this little part in purple, that's a little bit tricky for some people. So that might warrant a little bit of extra attention and just playing around with it a little bit. But this is right. It's negative 243 over a to the 5y b to the 20th. If there's any questions on that tomorrow, I'd be more than happy to explain it a little bit further. Let's go to number 8. This is getting even more complicated. In number 8, let's see what we have here. We've got a fraction to a negative exponent, plus the fraction itself is made up of a lot of different things. So I'm going to treat this at first like we treated number 6. A fraction to a negative exponent, there's a rule that says reciprocate the fraction and make the exponent positive. So that's the one and only thing that I'm going to do to start. Okay, so I've reciprocated the fraction and I've made the exponent positive. Now, every single one of those factors, whether top or bottom, will feel the effect of that power of 2. So just going right down the line, I'm going to have 49, c to the negative 6th, a to the 8th, negative 4 squared is 16, a to the negative 6th, b to the 12th. Now we have a very similar situation here. that I had in the problem before. So I'm going to put a blob around that as well. So we've got to make a decision. How should we subtract so that in the end the exponent will be positive? Should I bring the a to the 8th down and join forces with the a to the negative 6, or should I bring the a to the negative 6 up and join forces with the a to the 8th? And at the same time, I also have this little problematic c to the negative 6, which is also a negative exponent. So there's a few things I need to contend with here. So I'm going to start by writing an equal sign and a fraction bar, and then we'll take it from there. All right, so 49 over 16, there's really nothing I can do there, so I'm just going to rewrite that. 49 over 16. Now, I've decided that I'm going to bring all the a's to the top, and the negative 6, once it crosses that fraction bar, will become a to the positive 6, giving me a net of a to the 14th. The b to the 12th on the bottom, I'm not going to change that at all. And that c to the negative 6, I'm going to bring downstairs, making it c to the positive 6th. And I think that's good. I think we actually got that one. And the trick really there is to go very slow and not do too much at one time. I find that if students do too much, it really ends up being a disaster. So we want to avoid any kind of disaster. Let's go to the last problem, number 9. Well, it's actually the last problem on this slide. There's one more after this. So here, what jumps out to me are all these powers of 0. Anything to the power of 0 is 1. So we've got x to the 0, which is just going to be 1. We've got y to the 0, which is also 1, but that's being multiplied by 20, minus 36. Then we've got negative 2 on the bottom. And then x to the 0 is 1. Y to the 0 is 1. So 1 times 1 is 1. So everything in that parenthesis chunk is another 1. So what we really have here is 21 minus 36, which is negative 15, over negative 2, which is 7.5. Now, if you decided to leave that as 15 halves, that would be fine. But just make sure you remember that two negatives divided make a positive. So there's one more example to go, and then we're done. Okay, we're on our last problem, number 10, and in this problem we're going to be multiplying a few things together and then subtracting the result from the product of a bunch of other things that are being multiplied together. So I think what I'm going to do to attack this problem is treat the left-hand side and the right-hand side as separate problems in the beginning, and then once I simplify each of those sides, then I will subtract and find the difference in between the results. So what I'm going to do is I'm going to identify the left side with blue and the right side with green, and we'll start with the blue side and start simplifying that. As I look at these three chunks, I see that the first chunk there's really nothing to do. It's 5a to the 4th, and that's all there is to it. The second chunk is negative 4a to the 6th, and there's really nothing to do there. The third chunk, though, is negative a cubed squared. So it's like negative a cubed times itself. So negative a to the 3rd times negative a to the 3rd. Well, the product of two negatives is a positive, and then a cubed times a cubed would be a to the 6th. This all turns into a to the 6th. So what I really have here is 5a to the 4th times negative 4a to the 6th times another a to the 6th. Now, for organizational purposes, I'm going to bring the coefficients out in front and all the powers of a to the back. When all is said and done, I end up with negative 20a to the 16th power. Now, moving to our green problem, we have negative 2a to the 4th. And in this little chunk here, this power of 4 is going to affect both the negative 2 and the a. So I'm going to think about it like this. Negative 2 to the 4th would be negative 2 times negative 2 times negative 2 times negative 2, or 16. And then a to the power of 1, then to the power of 4 is really a to the 4th. So that first chunk becomes 16a to the 4th. And the second chunk, negative a squared to the 6th, I'm going to think about that as negative 1a squared to the 6th. And then negative 1 to the power of 6, negative 1 to the 6th is just going to be 1. And then a squared to the 6th will be a to the 12th. So the whole second chunk is a to the 12th. Now multiplying these together, I end up getting 16a to the 16th. And my intention is to subtract these two results together. So what I have here is negative 28 to the 16th minus 16a to the 16th. And in the end, I get negative 36a to the 16th. So in summary, this lesson has been on using the rules of exponents that you initially learned in Algebra 1. The problems do get a little bit more challenging than in the Algebra 1 level, and my strategy is to go nice and slow, not doing too many manipulations in one single step. Be willing to do this in several steps and maintain organization and neatness as you go, and you should be fine.